Hey everybody, this is the video that I said I was going to make to help you out with some of the more challenging problems from your homework tonight. All right, let's just jump straight into this. This first problem is going to be similar to problem number 5, letters A and C. So here we go. All right, so what we've got here is we've got a big nasty product on the left multiplied by another big nasty product on the right. And what we've got to do is kind of break this down. So here's what I'm going to do. I'm going to think about this as we're going to multiply the 12 and the 8 together. We're going to multiply the A and the A together, the B and the B together, the C and the C. So basically we're going to take things that have common bases and multiply them together. So in my head, I'm just going to rearrange this and I'm going to think about it like this. It's going to be 12 times 8 times A to the 6th times A to the 3rd times B squared times B to the 5th times C to the 3rd times C. I mean, what we're doing is, this is just all multiplication. There's multiplication symbols in between these things that we don't write, all right? So this is all multiplication. So it's okay if we write this out and rearrange things so that we have our numbers together, our coefficients together, and our common bases together. So 12 times 8 is 96. All right, we know that when we multiply powers with the same base, we add the exponents. So A to the 6th times A to the 3rd is going to be A to the 9th. B squared times B to the 5th is going to be 2 plus 5 is 7. I'm assuming, by the way, that you remember your lecture today, or that you watched the other video that goes along with this that tells you how to do your exponent rules. C to the 3rd times C. Well, C is just C to the 1st, right? We don't write a 1 here, but this is C to the 1st, so this is going to be C to the 3 plus 1, which is C to the 4th. Okay, so this whole thing simplifies to just this right here. And that's all we can do. That's our final answer. So basically what I did is I just went through and I multiplied the 12 times the 8, the A to the 6th times the A to the 3rd, and you don't even need to write this step. This is just what's going on in my head. Okay, so that's how you approach problems like this. All right, let's move on to the next one. This problem here is similar to other problems from number 5. I believe it's D and F. I'm not entirely sure though. So what we're going to do here is we're going to make this a fraction. For me, fractions just make more sense. So what I'm going to do is I'm going to write this expression in the numerator. So this is going to be, why don't I move this over so I can use an equal sign? So this is going to be equal to 42x squared y to the 4th over this expression here, which is 35x y squared. And now we're going to do the same thing we did in the other problem. We're just going to kind of separate this out in our head. And I'm going to draw this. I don't want you to draw this, but what I'm doing is I'm separating this problem kind of like this. Okay, so in the end, I'm going to divide 42 by 35, which just means simplify. Okay, 7 is the common factor here, so this is going to be 6 over 5. X squared divided by x is just x. Y to the 4th divided by y squared, well, we're dividing powers with the same base, so that means we're subtracting exponents. 4 minus 2 is 2, so this will be y squared. This is your answer right here for this particular problem. Now, you could write it like this, and you can also write it like this, 6xy squared all over 5. These two things here are equivalent. Okay, I prefer this myself. But if you're working it through and you're canceling things out in the fraction and you end up with this, that's fine. It doesn't matter if they're both the same. Okay, so both of these totally acceptable. All right, our next problem. What we've got here is we've got a product being raised to a power two products being raised to powers, and then we're going to multiply those things through. So here we've kind of got an order of operations problem. Before I can multiply these things with this multiplication symbol, I need to expand this. I need to remove the parentheses and get rid of this exponent. So basically, I need to raise this product to the power. And we know that when you have a product to a power, you need to raise each one of these to the second power. So I need to raise m to the third to the second power. And I also need to raise n to the fourth to the second power. And after I've done that, I'm going to raise m to the second to the fourth power and n to the fifth also to the fourth power. Okay. You don't need to write this step out really. I mean, if you can just see that this is going to be m to the sixth by multiplying the 2 times the 3, that's fine. Again, I'm assuming that you know your exponent rules. If you don't, review your notes, review the other video I have about exponent rules. Okay, so here we go. M to the sixth, m to the third squared is m to the sixth, n to the fourth squared is going to be n to the eighth. And we're going to be multiplying this by m to the eighth, and n to the fifth time to the fourth power is going to be n to the 20th. Okay, when we multiply this through, we're going to multiply similar bases. So my m's are going to get multiplied together, and that's going to give me m to the 14th and n to the 28th. Here, I'm just multiplying powers with like bases. Okay, so powers with the same base. So I keep my base and add my exponents, just like we learned today in class. And this is your final answer. Let's go back. The key to doing this was, though, to make sure that you raise these powers to this power here before doing the multiplication. So it's order of operation. The exponent had to come before the multiplication to simplify this. Okay. And our last problem. Okay. So this one is kind of throwing everything at you. We've got fractions being raised to powers. We've got products being raised to powers. We've got a little tricky 15 that we've got to deal with that's being raised to a power. So let's go ahead and work this thing out. First things first, let's raise things. Sorry. Layla, get in here. You're ruining my video. All right. So right now we're raising these fractions to these powers. Let's go ahead and do that. So 3c squared to the third power is going to be, I've got to raise the 3. Oops. The 3 gets raised to the third power because it is a factor. The c squared is going to get raised to the third power. C squared to the third power is c to the sixth. Okay, that's that's raising a power to a power, that rule. D to the third power is going to be d cubed. We're going to be dividing this by, 5 to the second power. And I'm just leaving things in exponential notation. So I'm not writing 25 here. I'm just going to write 5 squared. C to the third to the second is going to be c to the sixth. D squared to the second power is going to be d to the fourth. And let's go ahead and expand this over here. Now this is the tricky part. By the way, this is very similar to question 6D. Now 15 happens to be 3 times 5, so I'm going to write it like that. This here is going to be, I'm going to think of this as being 3 times 5. And I'm going to raise both of these to the fourth power, and that's going to help us simplify things later. Okay, so this is going to be 3 to the fourth power times 5 to the fourth power. And d to the third raised to the fourth power is going to be d to the 12th. Because we're raising a power to a power, we multiply our exponents. I haven't drawn on this thing in so long. It's very difficult. Okay, and then we've got c squared to the fourth power, which is c to the 8th. Okay, once we've done that, I'm going to go ahead and flip this fraction here because this is being divided. It's this fraction divided by this fraction. So I'm going to take the reciprocal of this fraction and change this to multiplication. So here we go. We've got 3 to the third, c to the sixth, over d to the third times this reciprocal, which is going to be d to the fourth, over 5 squared c to the sixth times 3 to the fourth, 5 to the fourth, d to the 12th, and c to the 8th. Okay, and from here, all we're going to do is we're just going to start canceling things out. When you're multiplying fractions like this, you can cross cancel the same way we do with other fractions. So just like when you have 2/3 times, let's say 6 over 8. Okay, we can cross cancel. We can cancel out the 3, and that'll give me a 2 here. And when I'm cross canceling, I'm really dividing things out. And I could cross cancel the 2 and get a 1 and get a 4 here. And then I could get, so we can do that with these variables as well. When you have common factors that are, even though this c is in the denominator of this fraction, we can still cancel things out here. So these 6 c's are going to completely cancel out. 3 of these d's, cancel those out. We're going to be left with 1d here. Okay, this is like d to the fourth divided by d to the third. So we're subtracting from this power here. I can cancel 2 of these 5s with 2 of these 5s, which will give me 5 squared. And that's about it. I don't see anything else. There's no c's to cancel here, and I've canceled everything else out of the denominator. So let's see what we're left with. It's going to be 3 to the third times, well, here's a 3 to the fourth, so that's going to give us 3 to the seventh. I've got 1d times d to the 12th. That's going to give me d to the 13th. I've got a 5 squared here. That should actually go here. Let's put that 5 squared just to be consistent. And then in the denominator, the only thing that's left is c to the 8th. Now, I wouldn't throw a problem this complicated at you yet, but I think it's a good thing to challenge yourself and try. Okay, so this is kind of like I said, this is them throwing literally everything they can throw at you. If you had trouble with this one, don't worry about it, or leave a note in the comments. All right, good luck. I hope you found this helpful.